This is a video solution for the QueryString test task, which is to write a table of test cases for the QueryString class, which is given here, and then to translate those test cases into JUnit unit tests. In this task, I haven't actually given you a complete implementation of the QueryString class. What I've given is called a stub class, and that means that the methods in this class, rather than doing the proper thing, simply return some default values like null, false, or 0. That means that this class doesn't work, it doesn't do what it's supposed to do, and when we write tests for it, we should expect those tests to fail. If they do pass, then that will just be by coincidence. In order to test this class, therefore, we need to understand what it should do rather than what it actually does. And this is normally what happens when we're testing a class. We need to think about what the class should do rather than what it actually does. Because sometimes a class will have a bug. We don't want to know what it actually does. If that's incorrect, we need to understand what it should do. So what does it promise to do? And this class represents a query string, which is something that can appear in a URL when you make a web request in a browser. And a query string might look something like foo equals bar and baz equals 1234. There's an example in this comment at the top of the class. And if you want some more information about what a query string is or what they're used for, you can follow this link to Wikipedia. What we're going to do is read the comments on these methods to understand what each method is supposed to do. Before starting, we can already see that the constructor of this class takes one parameter, which is a string, and that will presumably be the query string itself. The first method is named getParameter, and this takes a string as its input, and this parameter is called name. So this should be the name of the parameter that we're getting. And this method promises to return the value associated with that parameter in the query string, or it returns null if the parameter does not exist. And this method returns a string. So it returns either the string, which is the value associated with that parameter, or it returns a null if the parameter does not exist. The next method is named hasParameter. Again, this takes a name of a parameter as a string, and that's the input for this method, and it returns a boolean, true or false, determining whether or not that parameter exists in this query string. The third method is named getParameterOffset, and again this takes the name of a parameter as its input, and this method promises to return the character offset of the start of the parameter's name. And therefore that's an int, that's the position in the string, or the index in the string of the start of the parameter's name. And it promises if the parameter does not exist, then -1 will be returned. And obviously -1 is not a possible index in the string, so we can tell that apart from the success case. And finally, there's a method named decode. This is a static method, so we can tell already that this won't have anything to do with this data field. The actual string that comes into this constructor when we construct the query string object won't be available to the decode method. So this does not depend on the actual data of the query string. What it says is it decodes a URL encoded string. And for more information on what URL encoding means, you can follow this link to the Wikipedia page on %encoding, which is also called URL encoding. And this method takes one parameter, which is a string, and it returns a string. And this decodes a URL encoded string. So if the input string is encoded by the %encoding scheme, then it will return the decoded version of that string. Now that we understand what each of these methods is supposed to do, we can start writing a table of test cases. We can't start by writing manual tests of this class in this task because we don't have a functioning version of this class to see that those tests produce the correct outputs. So in this case, and as usual, we need to think logically about what these methods are supposed to do in order to write correct test cases. Again, I have an editor with a table of test cases where each row in this table will be one test case. And for this task, I haven't asked you to write a specific number of test cases. What I've asked is just write as many test cases as you think will be useful for testing this class. So I'll be writing quite a lot of test cases in this example. A good solution to this task wouldn't require as many test cases as I'm writing, but I'm going to be thorough, and hopefully I'll cover all of the test cases that you might have written yourself. The first method here is named getParameter, and it will be useful for us to write some test cases to test this method. And I'm going to write several test cases because there's several different cases for the input string that we're giving it. For the test data, we're going to create a query string object using the test data that's provided in the task. That's this string here. So my input is going to be a new query string object with this string. The action that I'm going to perform is that I'm going to get the parameter associated with the parameter name, and that should give me Alice for this query string. Let me see if I can make this a bit easier to read. So we're going to get the parameter name, which is Alice in this case, so that should be returned as a string. I'm going to use the same query string for most of these test cases, but for some of the later test cases, I'll be using a different query string. Let's also test that when we get the parameter age, that's age with a lowercase a, that we should get 19. And this 19 will be a string because the getParameter method promises to return a string. So it's not possible for this method to return 19 as an int. We must check that it returns 19 as a string. We can also check the getParameter for country, which should return the string UK with capital letters. There's another test case for the getParameter method, which is to test that it does actually return null if the parameter does not exist. So I'm going to get parameter of occupation, and because there is no occupation parameter in this query string, I should get null. And that's a null value rather than a string containing the text null. This null is a special value in Java that indicates the absence of a result or the absence of an object. I think this is enough tests for the getParameter method. Let's also test the hasParameter method. And it will be worth us testing the name, which this parameter does exist, so I should get a true. We can test the age, and this should return true as well, because this query string does have age as a parameter. Let's also test one that doesn't exist. Let's take occupation. So this should give me false. And let's test one that could be confused for a parameter that does exist to detect a possible bug in this class. If I have a parameter named count, then that's the first 5 letters of this parameter country. So I don't want this to return UK. I don't want it to be confused with the country parameter. I want it to know that count is not actually a parameter of this query string. So I should get a false here. Let's test the getParameterOffset method. And this is perhaps the most difficult of these methods to understand what it's supposed to do. If we understand what character offset means, that's the index of the start of the parameter's name, as it says in this comment. So if we call getParameterOffset with the parameter name, we would expect to see 0 as the result of this method. This method should return 0 because name appears, or the start of this parameter appears at index 0 in the string, right at the beginning of the string. Let's also test another one where we're not going to get 0. If we test the offset of age in this string, then we'll need to use logic to work out what the correct result of this is. So let's count from the beginning. This is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then there is the start of the age parameter. So this method should return 11. And let's also check that we do get a -1 when the method promises to return a -1. So if the parameter does not exist. So if I call getParameterOffset of occupation, then I should get a -1 for this test. For the next test, I'm going to test an empty query string, a query string with no data in it. And I think it's worth testing this kind of empty case because often that's a good way of detecting the most obvious bugs. And of course, we do have web requests where there is no query string, where the query string is empty. So it's worth testing this case as well because it is a realistic input. Let's test that the empty query string does not have a parameter. So this should give me false. And let's also test that it returns null when I get that parameter. And false should have a lowercase f. The final three tests, we're going to test the decode method. And this is a static method, so I don't need an object to test this method. But I do need a string as the input here. So we're going to use the string that's provided in the test case here, which is hello %2c plus world %21. So this is the string we're going to test in this case. And we're going to call the decode method. And what I expect when I decode this is that the %2c will decode as a comma. So that will give me hello, comma. The plus should decode as a space. Then I have world, and then %21 should decode as an exclamation mark. And this is a string, so I want double quotes around this. Now, if you're not sure why these decode as this, then what you could do is put this into a web browser and see what it actually decodes as, or you could do a Google search for the percent encoding scheme, or follow the Wikipedia link here to work out how this should be decoded. But this %2c is the hexadecimal ASCII code for a comma, the %21 is the hexadecimal ASCII code for an exclamation mark, and the plus is the way that a space is encoded in this scheme. We should also test that something that doesn't need it decoding will be decoded anyway, such as the string Alice. When I call the decode method here, I expect this string to stay the same because there is no decoding to do, so the result should just be the string Alice with nothing different. And then there's one more test I want to do, which is when I get this whole query string as my input. So let's create a new query string object here with this query string, message equals the encoded hello world. Now when I call get parameter with the message as the parameter that I want to get, instead of returning the encoded version of this message, I want the decoded version of this message. So this should return hello, comma, world, exclamation mark. And what that will test is that the get parameter method is correctly decoding the value of the parameter when it returns it. This should be the correct behavior of this class because there's no particular reason that someone using the class would want the encoded version of this parameter. It's more likely that they would want the decoded version of this parameter when they call this method. Now that we've written our table of test cases, we can translate these into JUnit tests. And as you can see, I've already put the stub class for QueryString in my BlueJ project, so we can use that to make sure that our unit tests will compile. But because we're working with a stub class, we should expect that our unit tests will fail, or if they do pass, it will just be a coincidence that they pass. To start off with, we're going to create a new class named QueryString test, and this will be a unit test class. I'll click OK here. Now that I have this unit test class here, let's edit it. The first thing I'm going to do is just delete some of this code that's given to us automatically. I don't need these two imports. I'm just going to have my test and my assert methods. So those are the only two import statements I need. Let's get rid of this comma and all of the body of this class, which is just given to me by BlueJ automatically. And we're just going to write our own tests here. Most of these tests use the query string with name equals Alice, age equals 19, country equals UK. So we're going to declare a query string here equals new query string with this data, name equals Alice, ampersand, age equals 19, ampersand, country equals UK. So that's my query string that we'll be testing. And then we're going to write one unit test method for each of the test cases in this table. So we'll just work one by one. I need the @test annotation for a unit test, and a unit test method must be public, and it must be void. And let's call this one test first parameter. and this method takes no inputs. All we want to do is assert that Alice is what I get when I call QueryString.getParameter name. So that's the action that I've said I'm going to test, and this is the expected result that I've said I'm going to see. Just a caution here, if you have written this in a text editor or something like Microsoft Word or any kind of WYSIWYG editor where you get these fancy quotes, then try to avoid copying from your editor into the code, because these quotes are not the correct symbol to put in your actual code. You can see that these two double quotes are the same character, whereas these two double quotes in my expected result are not the same. So if you do copy from this table in your word processor, then you will get syntax errors on things like those quote marks. Let's write the second test case. Let's call this test second parameter. And these obviously need different names because they're different methods. And what we're going to do is assert equals that 19 as a string is what I get when I write QueryString.getParameter age. The third unit test is getting the country, so at test public void test third parameter assert equals, and the country is UK in capital letters, and we're going to call QueryString.getParameter country. And then we want to get the occupation parameter, which should give us null. So this will be at test public void test non-existent parameter, because this parameter doesn't exist, it's non-existent. We're going to assert null when we call QueryString.getParameter occupation. So here I'm using assert null rather than assert equals with null, because this is a shorthand assertion method that I can use because I've got this wildcard import here. So I'm importing assert.star. That will give me all of JUnit's assertion methods, including assert equals and assert null. Let's test the next one, which is the hasParameter method. This should be public. So I'm calling this test hasFirstParameter. And what we want to say is that I'm going to get a true from this, so I'll use the assertTrue method. And this will be QueryString.hasParameter name. The next two of these are fairly similar, so let's copy and paste this code. So we'll test has second parameter, and then we'll test has non-existent parameter. So the second parameter is age, and the non-existent parameter is occupation. And in the non-existent case, this should return false rather than true, so I'll use the assert_false method. Let's continue. We want to test that I get a false if I ask for the parameter count. And this is a worthwhile test because there is a parameter named country. So if I ask for the parameter count, then I don't want that to be confused with the parameter named country. So let's say test has similar parameter, and this again should give me false. Next, we're going to test the getParameterOffset method. So at test public void test first parameter offset. And for this method, we're going to assert that I get a 0 when I call getParameterOffset with name as the parameter. So assert equals, the correct result is 0, and the action I'm performing is QueryString.getParameterOffset of name. Let's do the same for age. So test second parameter offset is a good name for this method. And in this case, the correct offset is 11. Then thirdly, we have a parameter offset of -1 when the parameter does not exist. So let's test that. Public void test non-existent parameter offset. And in this case, we're going to assert equals with an expected value of -1. This is get parameter offset of occupation. And you'll notice that I'm using the same non-existent parameter for all of these test cases, occupation, occupation, occupation. By using the same non-existent parameter, that helps me to debug when I'm using these tests, because I know that if this one passes but this one fails, then it must be the get parameter offset method that's broken rather than the has parameter method. Whereas if, for example, the get parameter offset method failed and also the get non-existent parameter failed, then it would likely be that the get parameter method is correct, but it failed due to the bug in the parameter offset method. Okay, so the next test I want to do is for a empty query string. So in this case, I'm going to write public void test empty query string. And an empty query string should have no parameters. So first let's create our empty query string. And the parameter for the constructor here is just an empty string. And then we want to make two assertions here. First, assert false that this empty query string does not have a parameter called name. And then if I ask for that parameter, I'll get a null. So that's my empty parameter test. Then we're going to have two tests of the decode method. So I'll call the first one test decode because there is some decoding to do. So first let's call this decoded equals QueryString.decode, and then this string is hello %2c plus world %21. So that's the encoded version of this message. And then we're going to assert equals that the correct message is hello, comma, space, world, exclamation mark, and then the decoded version of this message should equal this hello world string. Let's write our test of public void. This is the nothing to decode, so test nothing to decode method. In this case, we expect that when we decode the string Alice, we should get the string Alice and nothing should change. So let's say string decoded equals QueryString.decode of Alice. And notice here that I'm using QueryString with a capital Q because this belongs to the class. So it's a static method. I don't need an object to call it on. So the capital Q means the QueryString class here. And all we want to do is assert equals that my expected result Alice is what I actually get. So the decoded string should be Alice. There's one more test to do. And this is the get encoded parameter test, where I have the messages encoded in the query string, but when I call get parameter, I want it to be decoded. So let's call this test encoded parameter. So let's say string, first I need to create this query string, don't I? So query string encoded string equals new query string. And this will be message equals hello %2c as the comma, plus is the space, world %21 is the exclamation mark. So this is my encoded query string. And then we're going to get the decoded version of this parameter, which is the encoded string dot get parameter of message. So when I get the message parameter from this query string, I should get the decoded version of hello world. So let's assert that hello world exclamation mark is what decoded actually is. So this is a complete translation of these test cases into JUnit test methods. If I compile this class, I'm expecting to see no syntax errors, and I do. And this time when I run these tests, I should see a lot of test failures. So you can see that there are some of these tests that are kind of passing just by coincidence. These are the ones where we were testing for a null or a false or a 0. And these tests have passed just by coincidence because the stub version of this class returns null, false, or 0 for these methods. But the rest of these tests, we can see that they fail. For example, this test, the expected result was hello world, but we actually got null because this stub method returned a null. So overall, 10 of the tests that we've written fail, 5 of them pass by coincidence. So this should be the end of this task. This would be the complete solution for this task. What I'm briefly going to do is show what happens when we run these tests against a correct implementation of the QueryString class. And here's one I made earlier. This is a correct implementation, which I've also provided to you. So what I'm going to do is just replace my stub class with this implementation. And if you want to know how this implementation works, I've written some fairly descriptive comments throughout these methods, but we're not going to bother about that now. All we care about is that my tests should now pass. And we can see here that all 15 of these tests pass. And this gives me some confidence that these tests are sound, meaning that they do test the right thing. However, I shouldn't be 100% sure that my tests are correct just because they pass. We should never use passing tests in general to test our tests. The only way to test our tests really is by reading them and using logic to decide, is this actually the correct answer? Has this test been written correctly or not? And it helps if our tests are simple enough so that there are only a few lines of code, and those lines of code are simple, and the expected results are obviously that's the expected result for this test. In general, we don't have a correct version given to us by someone else of the class. What we have is a version where we don't know if it's correct or not, and that's why we're testing it. So in general, we can't just run our tests against a correct version of this class to see if the tests are okay. But in this case, especially in an academic context where you can get a sample solution, I recommend running your own unit tests against this correct version which I've provided to you. And if any of your tests fail, then the chances are it means that that test is incorrect. So this is a complete solution to the QueryString test task. Let's end the video here.